Hello, we are from P10 Group 3 and the team members are Brian, Yifang, Megan, Kaho, Ernest and I, Yongjie. So for this presentation, I'll go through our UML diagram and talk about the purposes and responsibilities of the different managers as seen in this content page. Here's the overview UML diagram for the entity management. As you can see, we have an abstract entity class which extends to movable entity and static entity, both of which are also abstract classes. The entity manager as shown has an aggregation relationship with the base abstract entity class. There is also an iMovable interface which I will explain further later on. Okay, the abstract entity class. This class basically serves as an abstract class for all other entities and have common attributes that all entities have. For example, the XY axis, width, height, and the Boolean attributes on whether the entity is collidable or removable. The class also has the basic getter and setter functions for all other classes to call. The first child abstract class or entity is the movable entity class, where it has the attributes velocity xy and the affected by gravity Boolean status. These attributes are mainly utilized by the movement manager so that the positions of the entity can be updated. The movement type attribute is used to assign the application movement classes so that the movement manager can use the iMovable interface method to update the movement of the entities. The other special attributes are like frame duration, atlas, animation, facing left, and state time. These attributes are mainly used for the animation of the entity. The movable entity also has the standard getter and setter methods for its attributes. The special methods are like set animation state and set movement type. Set movement type basically defines the movement behavior of the entity when it receives the movement class that implements the iMovable interface. Whilst for set anim state, it basically takes in a string and finds the animation name in an animation file that has a .atlas extension. The second child abstract class or entity is the static entity. The only special attribute it has is blocks texture, basically signaling the boundaries of the entity to be utilized by the collision manager. The method getBounds basically provides the boundaries of the static entity. Okay, the entity manager is basically in charge of managing all entities in the game. It provides public methods like draw to render the entities and get entity lists which will be utilized by other managers to interact with the entities. Finally, here are some examples of the application entities. First three classes extends from the movable entity, whilst the block class extends from the static entity.
The Game Master class manages all the core systems of the game. It handles the game setup, lifecycle, and cleanup. It's responsible for initializing and coordinating key components like entity management, movement, collision detection, and more. It sets up managers like Entity Manager, Movement Manager, and Collision Manager to control game objects, movement, and interactions. It also loads the game map and sets up the camera for a smooth 2D view. The Scene Manager class is responsible for handling the different screens in the game. It controls screen transitions. It also manages the main menu, preferences, application screens, and even the endgame and win screens. The class uses constants to represent each screen, making switching between them seamless. The Output Manager class handles all audio in our game, such as sound effects and background music. It manages sound effects like jump and boom sounds, ensuring actions feel immersive. It can also control background music, allowing us to adjust the volume or disable it. The Input Manager handles player input in the game. It tracks key presses for movement and actions. It ensures that the game responds to player controls, whether they are navigating the world or performing actions like jumping. It helps translate player input into game actions, making the game interactive and responsive. The Movement Manager class is responsible for handling the movement and gravity of all the movable entities in the game, such as characters or objects. It makes sure that each movable entity has its movement updated correctly. It calculates their new positions and ensures that gravity is applied to them when needed, helping to keep the game world dynamic. The role of Collision Manager is to manage collisions between entities in the game. It detects when two entities collide and resolves the overlap by adjusting their positions. Additionally, it ensures that entities do not move out of the game boundaries by checking for boundary collisions. It is also responsible for triggering key events in a game, such as when the player wins or loses. If the player successfully interacts with a win condition, like reaching a specific entity, the game triggers a win screen. Conversely, if the player collides with an enemy in a fatal way, a game over screen is triggered. This helps keep the game world intact, ensuring entities move within the boundaries, and triggers important game events when collisions happen.
Okay, so now we're demoing a 2D platform game that was built using our abstract game engine. Okay, going to the preference screen, as you can see here, is actually handled by the scene manager. I'm adjusting the music volume, which is actually handled by the output manager. I can even mute the game, for instance. Yep, okay, let's go into the game. Okay, all the entities you see are actually handled by the entity manager. The ghost, the slime, and the acorn, including the player here. Okay. Then the input of the keyword is handled by the input manager, and you can listen for WASD, up, down, left, right, and spacebar keys, which I'm pressing, and you can see a player fox move. Okay, when the player jump, the jump sound is also actually handled by the output manager. Okay, these are all movable entities, and they are actually managed by the movement manager. Okay, as you can see here, my fox actually got hit by the slime, and the game over screen showed up. This is actually handled by the collision manager. Yep, as you can see, when I touch the acorn here, which is actually handled by the collision manager, the win screen shows up. Yeah, that's about it.
Hi, I'm Ernest, and I'll be explaining how we have extracted the creation of our entities. So we have 5 different classes that I'll be presenting today, and each one of them have adhered to the single responsibility principle. So I'll start from the beginning, which is Entity Factory. Entity Factory provides a centralized way to create different types of entities. We have 3 different kinds of entities that we have instantiated this time, which is player, enemy, and win entity, without calling the code to know the details of the construction. Notice that Entity Factory does not care about the specific details of how each entity is created. It just invokes the create method. So how it does that is by 2 helper classes. So there's entity config, which you can think of as giving orders to Entity Factory to create the entities, as well as entity creator. Entity creator is an interface that you can think of as being able to create each of its specific entities where it needs to. How these entities are instantiated for this demo is through this class, demo entities instantiation. So this class also helps to show how games will be created when there are many levels, how each entity is created are in bundles, and each of these entities have its specific parameters to then be instantiated. When these entities are instantiated in the screen, and the entity manager is then managed by the entity manager. Entity manager would manage the life cycle of these entities, such as adding and removing from the list. Entity manager is also responsible for drawing the sprites of these entities.